We're their exclusive genetic rescue partner. We're working with elephants in Botswana, we're working with elephants in Kenya. So anybody can use our technologies for free, right? We're working on chytrid, a terrible fungus in Australia. And so if that's not enough, I found out that, that there's only 15 of those of red wolves back in the wild in North Carolina. So I met with the upcoming governor.
Are they in other states as well? Or is
No.
it just...
We'll get to that. We'll get to that. So they're only recognized by U.S. Fish and Wildlife there. But this incredible woman from Princeton, top of her field, she's one of the top wolf geneticists in the world, Bridget Von Holt, identified a population of wolves in Louisiana that have red wolf-like characteristics. So she started darting them, taking samples, and what she found is they actually have more quote-unquote red wolf in them than the red wolves that are being identified in North Carolina.
And is it part of the problem they're inbreeding with coyotes?
Yeah, but they've all been like these guys, the ones in North Carolina have all inbred with coyotes. All the red wolves have some coyote in them because
they look like coyotes.
Well, because the ones in North Carolina even look more like coyotes.
Really?
And because the reality is every single species is what's called an admixture. Everything is inbreeding with everything on some level, right? And so everything in life is an admixture. It goes back to the Neanderthal.
So this binary idea that we have is silly.
It's a human caused construct, right? And it's insane. So I went to some folks from the last administration, right? And I took some data with me, and I said, hey, we really want to help this Red Wolf program. We don't need any money. We open source all of our technologies, and we've used a technology that's non-invasive for cloning, where we actually take a vial of blood, we isolate what's called endothelial progenitor cells, basically the inner lining of your blood vessel, right? Because there's no nucleus in blood cells. So we catch those, and when we catch those, we then isolate them, we grow them, and we clone from them, right? Which is amazing because if you think about typical cloning from an animal welfare perspective, a lot of times you have to anesthetize the animal, you have to take ear punches, skin biopsies. It's actually pretty invasive, terrible process to do cloning. We can simply do it. Every single zoo takes blood from their animals to check certain levels and whatnot. We give blood all the time. And so it's a very non-invasive, it's about as non-invasive as you can get, right? And so we found a way, which we're open sourcing on Tuesday, is open sourcing this model of how you go clone from blood, which is a game changer for biobanking because now you don't have to go hurt an animal, take pieces of the animal, anesthetize the animal. We can just take bloods and put them in freezers and be able to bring them back or clone them if there's a lack of genetic diversity using this thing. So I went out to Washington.